I don't see YouTube started yet.
I can check on my phone.
Okay. Okay. All right. Let's wait 20 seconds. Yeah, we're good now. I think we're all right.
I'll start my video when my presentation starts.
All right, so let's give it 5 minutes. So let people connect. We have some people on YouTube and we have some people on Zoom. And welcome everyone. Let's wait still. How many people have joined on Zoom, Mike?
We have 18.
18, okay. And we have like same number so far on YouTube. Let's give it 1 more minute and we'll start. Because people keep joining, so. Actually, all right, let's start. So again, welcome everyone, and thanks for joining us. Today, we're gonna meet and talk about FHIR profiling, and we have some thought leaders from the FHIR community who joined us to present their solutions, discuss the problems they solve, and you know, at the end of the day, our speakers and attendees of the meetup will get a chance to get together and for a like roundtable conversation between everyone about the topic. So first, again, welcome everyone and thanks for joining us. A couple of words what we're doing here. So we're doing a FHIR meetup, and we started as offline meetups to complement online community, which was very active at chat.fhir.org. But then with pandemic, we moved online, and we found that there is a lot of interest, and FHIR engineers and other health IT professionals are happy to join and discuss FHIR topics. So that's what we're doing now. We have a couple of links to share with you. So one is we have a Telegram chat, not to pull anything from the chat.fhir.org, FHIR developers chat, but to ask quick questions about FHIR meetups and maybe propose a presentation, a new topic, or I don't know, ask any questions. So please join if you use Telegram. And all these meetups we had, I think this is the 5th one. We record them, and you can watch previous presentations at Health Samurai YouTube channel. There are a lot of interesting stuff there, so please check it out if you're interested. I want to try to give an update about what happened with FHIR and presenters, their companies over the last couple of months between the 4th FHIR meetup we had and the 5th one. I think major event which I was able to pick from everything what happened was, I mean, finally came the deadline from CMS, interoperability and patient access API rule. And so starting July 1st, CMS began to enforce requirements for CMS regulated payers to provide patients with API to their provider directory and their claims, clinical data, and drug formulary. Health Samurai participated in some of these projects, so I think it's a big date for us. Any big news from our speakers? What about Geimer and Lantana Consulting Group? Can you share any update about Lantana?
Yeah. So thanks, Pavel, for inviting us. Yeah, Lantana has been doing a lot of work lately with the CDC and or the National Health and Safety Network at the CDC, known as NHSN. Also working with folks from Leidos, from the Saner Group, and various other Cerner and other organizations. We'll be doing a big demonstration at the HIMSS showcase around NHSN reporting, how we're starting to automate that and going forward, you know, for NHSN and public health reporting in general, moving away from manual data entry and using FHIR to auto-populate information that's submitted for reports to NHSN and state and local public health agencies. So that's exciting. And if anybody's going to be at HIMSS in person or virtually, we welcome you to come over and take a look at what we're doing. It'll be under the CDC banner.
Thank you, Rick. And any exciting news updates about Mitra? Hi, Mark.
Yeah, hi, Pavel. And thank you to Health Samurai for inviting us to present FHIR Shorthand. It's been a really busy year for MITRE. We've got a host of projects that are very topical, dealing with equity in health, and of course responding to the COVID crisis. And I'll turn the clock back for one of the important things we've done last year. Actually, a little bit more than a year ago, governments started to track people who were coming on travel or exposed to individuals that had COVID and put them in quarantine. And you wonder, you know, how does anyone keep up with the people that are in quarantine? So MITRE responded by putting together some software called SARA Alert. SARA Alert, if you Google it, S-A-R-A, it's a very elegant piece of software that has helped public health officials in over 20 jurisdictions from Puerto Rico to county level to trace individuals who are at risk of developing symptoms and allow the quarantined person to communicate over cell phone to see how they're doing and check in each day, and eventually, hopefully, get released from quarantine. So that's been a really exciting project. We've monitored over 4 million people, as I say, in 20 jurisdictions. And that's one of about 200 projects that MITRE does in health for everyone from HHS to CMS to ONC to CDC and FDA and more.
Thank you, Mark. Right, so that's enough for updates. So about today's event, we're gonna have, as I said, 3 presentations. The whole event we plan like perhaps 2.5 hours. Presentations will be for 30 minutes plus 10 minutes for QA. So please prepare your questions and submit them to chat on YouTube or chat on Zoom. I will monitor both sources of the questions, and we'll try to ask speakers. Whoever is on Zoom, perhaps you can even ask yourself. And also, yeah, I think that would be it. If anybody from YouTube want to join Zoom meeting and doesn't have a link, we can share it as well. Just reach out to us. Yeah, and at the end of third presentation, we will have a roundtable for all the speakers. So let's start, and starting with Rick Geimer, who is the Chief Innovation Officer of Lantana Consulting Group. And we chosen Rick to be the first presenter, probably because I think Lantana's tool, Trifolio on FHIR, for FHIR profiling is the most traditional, I think, approach to profiling. And maybe I'm mistaken, but I think it historically was the first one among the presenters today. So anyway, Rick, welcome. Please introduce yourself and tell us about your tool.
Sure. So I'm gonna actually, if someone can allow me to present, there we go. It's still saying I cannot share my screen. There we go. Okay, now it's working. Okay, share. And hopefully folks can see my presentation. Let me go into presentation mode. Oops, and swap presenter. Here we go. Okay, so welcome all, and Pavel, thanks for letting me join. So I'm, well, here's the basic agenda. I'm Rick Geimer, who's this guy. As Pavel said, I'm the Chief Innovation Officer at Lantana. I'm also one of the co-chairs of the FHIR Infrastructure Working Group at HL7 and a member of the CDA Management Group as well, though I'll, basically I'll be retiring from that in the fall. Been around CDA and FHIR for a very long time, been an editor of many implementation guides like Consolidated CDA, CC on FHIR, and so forth. It doesn't mention it here, but I've got a really awesome ponytail going on, so I just had to do a shout out to myself for that. Trifolio on FHIR is the tool that we're going to be talking about. First of all, just a tiny bit of history. Trifolio was originally created as a CDA implementation guide creation tool, and had been it was the first one and probably the most widely used in the US for many years. When FHIR came about, we originally tried just retooling our existing code base to work with FHIR, but decided pretty quickly that we wanted to rebuild it from the ground up. So we did that. It is now a web-based tool for creating, modifying, and publishing FHIR implementation guides. It works with a FHIR server as the back end, so all FHIR resources are stored directly in a FHIR server. We do all of our testing around Happy. You could potentially use other FHIR servers. We just don't test against it. It would have to support the same, search parameters, operations, resources, etc. But in theory, you could use any FHIR server that supports what's needed for storing and working with implementation guides. It is cost-free and open source, and quite popular. It's got over 250 users, about 150 implementation guides, lots of profiles and value sets in there. So we like to think it works pretty well. It provides a development environment for creating implementation guides. You can drag and drop resources when you want to import them. It supports multiple versions of FHIR within the same interface. So you can log into Trifolio on FHIR and just select a FHIR STU3 Happy server, and it will work with all your STU3 resources. If you select the R4 version, it will work with R4. And we'll be adding FHIR R5 support soon. It supports HL7 publishing templates and integrates with the FHIR IG publisher. So what this means is if you're publishing HL7 implementation guides. All the tooling is present and all the templates are supported in order to do that and integrate with the CI build and things like that. If you wish to create your own implementation guides that are not published through HL7, you can do that as well. You could still use the FHIR publishing template approach, but design your own template with your own logos, your own copyrights and such like that, and your own look and feel. So let's go over some of the main features and functions. The primary functions are around creating and opening existing implementation guides, profiles, resources, and such. So when you create a new implementation guide, you can preview a draft of that implementation guide as it will appear when it's published. You can create and edit resources, for profiles, like structure definition. You can do, which will do profiles and extensions. You can create value set and code system resources, operation definitions, pretty much anything you would need in an implementation guide. You can also create and edit narrative pages via the integrated WYSIWYG Markdown editor. You can, as I mentioned previously, import by selecting and dragging, dropping files. This is really useful for things like graphics and example files and so forth. And lastly, it's got robust export capabilities. You can export a FHIR IG Publisher package so that you could actually run the IG Publisher locally on your system instead of running on our servers. You can export to GitHub. You can export a FHIR bundle with all the contents of your implementation guide. That's often used for backup, or if you need to make implementation guide wide search and replace changes across all resources, you can do that. And also for supporting folks like technical editors who don't really necessarily like working in a web-based format, we can actually export a Microsoft Word file so they can go and do the review and then make edits later back in the tool. And lastly, like I said, we can publish it for review via the HL7 IG Publisher. So the main menu that folks will interact with, and I'll show this in the demonstration shortly, is what we call the Browse Edit menu. This has a bunch of sub-items underneath it. The first three are associated around implementation guides. The View IG one lets you view an implementation guide as it will appear when it's finally published on the HL7 website or on your own if you wish to do your own IG. You can hit the Edit IG one. This allows you to go in and edit the key fields in an implementation guide, like the URL, the ID, the name, any dependencies and such. And then we have a bulk editing feature. This is used for folks who want to make changes across all the narrative content, so it'd be resource descriptions, markdown pages and such, all in one view. And this is useful if you want to just sort of search and replace the tool and make sure that all your spellings are consistent and such. You can also, through here, manage permissions for the implementation guide, assigning who is allowed to edit them, who's allowed to view, and things like that. The next few ones here are for browsing and editing key resources, such as structure definition, which is used for profiles and extensions, capability statements, and operation definitions. And we also support value sets. You can create value sets or draw code from multiple code systems. You can actually create your own code systems if you need to. Typically, most people editing implementation guides will use existing code systems like Loinc, SNOMED, and such. But there are occasionally cases where we need to create custom ones, or there are cases where people who have their own private implementation guides have created their own local codes and want to use them in their implementation guides as well. And lastly, we have the ability to edit and create FHIR questionnaires in the tool, because there are some implementation guides that we create that are more questionnaire-based than profile-based. And then lastly, we can edit or import examples. You often want to do this if you have a profile, say, for a condition resource, and you want the FHIR IG Publisher, when you run it, will give you a warning if you don't have an example for that. So this allows you to import an example, edit it, and the tool will actually also validate to see whether it's valid against your profiles that you've declared. and you can associate an example with a profile to do that. And then lastly, you can search across all resources on the FHIR server in case you happen to have resources that aren't typically used for profiling, and you've put them in there anyway. You can search for them. The import tab has a bunch of nice capabilities. The simplest one, I think, is actually the third bullet. I probably should have made that first. And that's if you want to import existing profiles or value sets and such. Often, I'll use that if, for instance, I'm working in the tool, but I feel like I need to go offline and it's just easier for me to edit the raw XML or JSON. I can do that, and then I can drag and drop them back into the tool, and it will import them automatically. Also, if I've got an existing implementation guide that was developed in another tool, such as maybe done with FHIR shorthand, as Mark's going to demonstrate, I could take the resources there and drag and drop and import them into Trifolion FHIR and work with them in a user interface. You're also able to import terminology from a variety of sources. I think the most useful for the US use cases that we've developed an integration with the Value Set Authority Center, or VSAC as it's called. It says from a spreadsheet, but actually we integrate directly with their FHIR interface. So if you know the OID for a value set, you can enter that and it will bring it directly in from the Value Set Authority Center. You can also import their the files from a spreadsheet. So you can export from VSAC as a spreadsheet format and drag and drop that in, and it'll work. You can also bring in image files like JPEGs and GIFs and such for inclusion in the narrative. And you can do import from GitHub if you've stored your implementation guide there. For export, the primary export, I would say, is the FHIR IG Publisher package. So if you built your implementation guide in Trifolion FHIR and you want to now put it into GitHub or the CI build, and you want to do that from your file system, you can do that. You can export it. It will create a IG Publisher package structured exactly the way it needs to be to run in the CI build. And then you can push that to GitHub locally. Or as I said previously, we've actually got a GitHub import-export capability, so you can do it directly from the tool as well. But I'll be honest, in my opinion, I usually do it locally because there's often one or two little tweaks I want to do before I put it in. So I prefer to work that way. We also have the capability to export an XML, XML or JSON, I should say, a FHIR bundle that contains all the resources in your implementation guide. I often use this for backing up implementation guides, keeping a local copy in case I want to make sure I've got it in case I make a mistake in the tool and wish to revert back. Though frankly, we've got a history function to do that. But I like having the whole thing available just in case. And last, we've got that Word document file for collaboration and review. When we create implementation guides, we actually call them projects in Trifolion FHIR. So when you create a new IG, you're actually creating a new project. And then that project will include an implementation guide resource and all the resources referenced in it, including any markdown pages and images, profiles, structured definition resources, all those. And Trifolion FHIR will manage all those as a project. And when you go to publish, it will gather all the pieces together, put them on our server, run the IG Publisher, and then provide the rendered implementation guide back in HTML for you to view directly. And so we always save the latest version of the published IG so that if you log back out and come back later, you won't have to rerun the IG Publisher. You can preview what was last run. And then also, we have robust permissions management around that, so we can state exactly what users you want to have permission to your IG. You have the ability to say everyone can get it, which we often do for public implementation guides, after they've been published by HL7. But while things are under development, or if you're creating an implementation guide for your organization that you want to keep private and only have authorized user access, you can do that as well. So for when you actually run publish, the first thing you want to do is you want to make sure that you're using the correct publishing template. By default, we use the provided HL7 publishing template, and that comes with certain restrictions around it. Like if you use that one, you have to make sure that you've selected the HL7 working group that is responsible for the implementation guide. You need to have correct copyright and stuff in there referencing HL7. And you have to meet certain HL7 publishing criteria, like having a, it's called a JIRA spec file and things like that present. If you choose your own custom publishing template, and there's instructions for doing that on GitHub. If you search for HL7 FHIR publishing template, I believe, you'll be able to find all that information, but Lloyd McKenzie set those up. And then you can choose your own publishing template. You don't have to follow all those HL7 rules. You can choose your own color scheme and so on. You also have the ability, when you're working with Trifolion FHIR, to choose what version of the HL7 FHIR IG publisher to use. So occasionally, even though we like to think of Graham Grieve and all the folks working with him as perfect, occasionally new versions will have bugs. And while you will always need to use the latest version of the FHIR IG publisher when you go to the CI build and when you try to publish, there may be times where there's a bug which is going to be fixed in 2 or 3 days, but you need to get your work done right now. So you can always revert back to a prior version to make your edits and to preview your IG. And you don't need to wait around for the IG publisher bug to be fixed. You can continue working. I'd say one of the biggest advantages for many folks is that it runs on Lantana servers. So that saves you from having to install all the dependencies that you need to get the IG publisher running locally, Java, Jekyll, all that, which can be, time consuming for an experienced developer. But for some folks who are non-developers, maybe they're analysts, it can become a real, roadblock for them because they maybe don't have the technical skills and understanding how to get all those dependencies installed. So if you use Trifolion FHIR, you can just bypass all that and trust that it's already been installed on our servers and it's going to run properly. We do note that the public version that we have available for folks to use is restricted to running 2 implementation guides at a time. Uses a queuing system. So occasionally, if you've got 3 or 4 people trying to publish simultaneously, which actually doesn't happen that often, you may be queued up and have to wait a minute or 2 before one IG finishes before your next one can begin. And then also all the logs from the FHIR IG publisher are actually streamed via a socket connection to the user interface, so you can see what's going on in real time. So enough talk, why don't I show how it works? So here's Trifolion FHIR. Now, live demos are always fraught with peril, especially since when I logged in this morning, I found out, because I'm going to be working in our dev system and in our dev server, so this will not affect any production implementation guides, but our lead engineer made a change this morning, which broke things temporarily, but we got it fixed before this. Hopefully there are no other changes going on. So the first thing I do is I'm going to log in. And as you notice, it basically has the typical logins that you'll see for most applications today that support OAuth. Here you can select Facebook, GitHub, Google. Here at Lantana, we use Microsoft for most of our OAuth stuff. So I'm going to log in with that. And voila, so it's, for some reason my profile picture is not showing up, but you've already seen my awesome ponytail. And I'm also logged into our development server. So we have the option to select what FHIR server we're going to use. I'm going to stick with the FHIR R4 Happy development server that we have set up. And I'm just going to go ahead and I'm going to create a new project. So for this one, it's going to show me this blank field with a lot of stuff that's missing. And I'm going to assume that I'm going to be creating a new HL7 published FHIR implementation guide for a console note. So I'm going to go ahead and start by putting this URL. Note this end of the canonical URL for this implementation guide also has this ID at the end, which typically what we're doing in FHIR these days is we're making that the package ID, the actual FHIR ID, and the URL all sort of sync up and match. And the area where you put in something more human readable would be in the name. In this case, I'm going to call it consult note IG, we'll just call it that. You can add a title if you want. Often that would just be the same thing, but with spaces, so it's a little more human readable. The version is required for HL7 IGs. I'm going to call it 0.1 since it's the draft. And I'm also going to specify that this is from the Structured Documents Working Group in HL7. So that's all the basic required material, but I know right off the bat that when I design this implementation guide, I'm going to use some of the profiles from the US Core implementation guide. So I am going to add a dependency on US Core. Now I can either do this manually by going in and typing all the URIs and such if I know them. But we've actually integrated with the FHIR IG registry. So you can just type in US Core, for instance, and select it. And not only will it bring it up, but it'll also show you all the versions that are available. Now I'm going to select the previous one because this was just released and I did notice a bug when we published with it. So I'm going to, that's a bug in the IG publisher, as I mentioned. Sometimes it has bugs. And then the last thing it's requiring here is that the jurisdiction field must be filled in. So I'm going to select US, since I've already said this is going to be US Realm IG using the US Core profiles. Okay, so now I can save this. And all the basics of my implementation guide are now here. The next thing that I'll want to do is I'll want to create some other resources to go in the IG. So I'm going to create a profile. And since I said I'm creating a consultation note, I'm going to basically use that same base URL as I did for my IG. In fact, I'll just copy the one there to show you what's different. Now, the way that FHIR URLs for an IG work is you've got this base portion here, which is, which all should be the prefix for all of them. And then you go the resource name and its ID. So in this case, I'm going to do a composition resource. I'm going to go composition, see if I spell that right, / consult note composition. I'm just going to use that as my ID. The type will be a composition resource. So I basically say this is going to be a profile on the composition resource. And I'm going to give it a name of consult note composition. Okay. And did I get oh, sorry. Yeah, I forgot the name should not have spaces. So it's giving me that red warning to note that I did something wrong. So I would actually change the title, which I can get to in a second after I do the basic creation, if I wanted to add the spaces. All right, and I'll just pass on that because I showed you how to do that previously. So now I'm going to go in here and I already mentioned that I want to use US Core for this. So I'm going to take the subject. Actually, I don't need to expand it. I'm just going to constrain it directly. I'm going to constrain composition.subject and particular constrain the type. So I'm going to, for this one, add a target profile because basically I'm saying that this composition.subject is going to have a reference pointing to something that must be a US Core patient. So here's the US Core implementation guide, and I've got the patient profile selected. The easiest thing is just to grab this defining URL from here and put it in. Now, if I were referencing a profile that was part of my implementation guide, I could actually select it here. But since it's an external implementation guide, I'm just going to put in the URL for it and be done. And that's enough for the IG publisher to pick it up and resolve those references. So I'm going to go ahead and do a save here. And then I'm going to demonstrate our import capabilities because the next thing I want to do is bind composition.type to a value set of consult note document types. So I'm going to go to the import page, and I've actually got here on my text file a FHIR value set resource that I grabbed actually from VSAC, but I'm just going to demonstrate the drag and drop import here. So I can go up and bring this in and do import. And now when I go browse edit value sets, I will see this here. I can actually bring it up, see all the metadata has been imported, and I can see how this value set was composed, and it's composed of these 5 link codes. Now, when I go back to browse edit profiles and extensions, I can go back to my elements tab, select type, and I'm going to constrain this and bind it to that value set. And now, since this value set, I actually imported it, I can actually see that it's here as part of the IG. If you see this checkbox here, show resources from the this implementation guide. This means I only want to see those that are already part of my IG. And I can save this. And now I've actually got a semi-complete implementation guide. I'm going to do one last thing. I'm going to go back to the edit the IG, and I'm going to create some narrative pages. So I'm going to add one first, and I'm going to leave this as the default home page. And under this, and that'll just be what appears when you land on the IG. And I'm going to add a new generic page underneath it and call this introduction. And if you notice, it already gives a file name of introduction.md because it's marked down. And then in here, I can go in and say, this is the intro page for this IG. And I can do things like selecting this and make that bold. And notice it'll put in the markdown syntax for me. So if I want to do intro page and say this is italic, that'll do all the markdown stuff for italic as well. And it's saying that I shouldn't have a white space at the end, being so nice there. And then I can hit OK and save. Now, at this point, I'm ready to publish this implementation guide. So I'm going to go here and I'm going to go publish, and this will run the FHIR IG publisher for me. So note that we've got a big thing here that says this page executes the IG publisher. This is not developed as part of Trifolium on FHIR. A lot of people don't understand that. They think this is part of our tool, but we're actually running HL7's tooling here behind the scenes. And we like doing this because A, it saves us work. We don't have to rewrite our own publishing system. And two, we guarantee then that if it publishes here, we're almost certainly going to be able to publish in the CI build because we're actually using the same tooling, the same resources, everything. Now, typically for a small IG like this, this will take about 1.5 minutes, but generally not too long. And as I said, all the information, the logs are streamed back in real time, so you can see what's going on. Generally, what we find is, it'll do that stuff very quickly, and then it'll start doing the wrap-ups of generating the outputs, and you can actually see how much time is elapsed that's going on. I expect this one to take about 1.5 minutes. Actually, it took a little bit less, took about 1 minute. So you can click on here now, and you can view the implementation guide directly in a tool. I typically like to launch it in a new tab, so I can actually see everything in its own view. And you can go on here, click on the artifact index, for instance, see our consult note composition. You can see all the tabs that you'd expect to see in HL7 implementation guides. So here's the differential tab. Here's the snapshot must support table. I didn't flag anything as must support, but the full snapshot one shows you everything that's allowed in the base resource and the changes that you made in the differential. And then you can do things like, I hope this link is going to work. Yeah, click on US Core Patient, and this will take you directly to the US Core IG. So those hyperlinks work. And the link to the consult node document type actually will take you to the Value Set Authority Center. Now it's probably going to ask me for my login because I believe it expired. Nope. I guess it's already here. And basically from here you can see the value set as it exists in VSAC. And the interesting thing here that I wanted to demonstrate is I drag and dropped an old version of the value set into Trifolium on FHIR on purpose, so that you can see that there's actually a later version on VSAC, and the tool is smart enough to make those links. So when you click on them, even if you had an old version in there, it'll bring you to the latest in VSAC and show you everything that should be there. So I think that's about it in a nutshell. I'll just briefly show you the export capability. If I do an export here of the FHIR IG Publisher package, so I'll put it in my downloads folder, and I can extract, or actually I'll just go into it, and it'll have the all the resources in that are necessary to run the IG. By default, it will not include the FHIR IG Publisher because that makes it a lot bigger. But if you wish to include the IG Publisher in your package, just so you can run it automatically without having to download it separately, you can select yes, and it will ask you what version you want to include. And then when you do an export, it will include the FHIR IG Publisher, as well as Windows BAT and Linux shell scripts to run it for you. And I think that's about it. I will pause now and hand it back to you, Pavel, or if we're ready to take questions, we can fire away.
Thank you, Rick. Thank you so much. It was very cool to see actually live demo, pretty much end to end of your product. Definitely we see how feature rich it is and handles a lot of complexities. Seems any questions for Rick?
Sorry, I forgot. I did actually have a couple more slides here. Just I think a summary of the benefits we have there, and I think we'll share this presentation, but we've got the URLs for folks who want to access it. You can also download your own copy. Like I said, it is open source, so if folks want to download and install a private version of Trifolio on FHIR, you can do that. And sorry, now questions.
Yeah, so let me check the chat. We have so far one question, and please be active. Don't be shy. Please ask everything. Don't hesitate. Manon Pancholi, hope I pronounced it right, asking is there a way to compare between two versions of the same profile?
Yes, there is. So there is a history tab here, which will show all the versions of it. And as you can see, I was playing around with this, creating new ones and deleting it. So not only will it show the versions, but it'll do a compare against them, show the changes as a diff. So that's available within the tool.
Thanks, Rick. Nikolai is asking how multiple authors may work on the same implementation guide at the same time. If you have any conflict detection or anything like that.
So yeah, we do that all the time at Lantana. We don't, but basically it's the same, conflict resolution that would happen if you have two users posting the same resource to a FHIR server. So the first thing we'll do when we open up a profile or any other resources, we'll do a get from the happy FHIR server. And while you're editing it, you're expected to be the one making the changes. And when you do a save, it'll put or post it back. We don't currently have any restrictions for if two people happen to edit the exact same profile at the exact same time. It's just one of those things that we don't see happening a lot. But if it were to happen, you would basically end up with, whoever clicks save first will get it in there, and the second person will create a new version. And they would potentially have to use the version history mechanism to resolve any differences there. Again, if it were something that happened a lot, we would probably build in more safeguards around that. But in our experience, at least when we've got multiple people working on IGs, they're typically doing different things and collaborating with each other. So like, one person will be editing profiles, the other person will be editing value sets, and someone else may be working on the markdown pages. So really, we just suggest best practices, in general, which is, talk to each other, make sure it works.
Yeah, communication is the key in every situation,
exactly.
right?
Yeah.
One question from me. So Trifolio on FHIR is open source, right? Do you have any contributions outside of Lantana for?
A few. We have had probably about a dozen or so people actually download it, install it locally, and start working with it. And yeah, they do send stuff back. I have to ask Sean McAvena, our director of engineering, what those changes are in particular. But we have had some contributions back, and happy to take them.
And what is the roadmap for the next year? Let's say.
One obviously is moving towards FHIR R5. Since that got pushed back a little bit, it's just from the HL7 perspective, it's pushed back a little bit on ours as well. But we'll be adding initial FHIR R5 support soon. The critical thing for us is that Happy has to support it, and there's a version of Happy out now that does support it, so we can start working there. We also want to do just a lot more user interface improvements. We notice that there's certainly areas where there's some redundant typing going on. You saw some examples when I create a new implementation guide. I create a URL and then I have to copy that ID portion and put it in the package and in the ID fields. So some automation around stuff like that will likely be areas that will help. Also, maybe more interactive validation within the editor itself. We do have a validation tab that'll show you the errors, but things like being able to highlight in a profile that you've done something that's a conflict right there would be more useful. That's a bit more tricky though from the UI perspective. But those are things that we're kind of looking at. And we also have a Jira page. One thing I should show you if anybody's using Trifolium on FHIR is if you find a bug or you just want to suggest a feature, you can go here and go request support, and this will bring you to our Jira page where you can go in and report a bug, suggest new features or improvements, or just send questions to the development team, and we're happy to respond to those. And whenever you submit a bug or a feature that goes into our queue, basically into our backlog. We obviously do Agile like everybody else these days, and we'll pull those in and triage them. And if it's a genuine bug, we'll be putting in our queue to fix. So that's basically how you interact with the development team.
Thanks, Rick. Any more questions from the audience? Last call. Vasil Herman is saying, I'm an analyst on FHIR data. Are there any use cases I can apply the tool for or nuances we should be aware of?
Certainly. I mean, if you need to create FHIR implementation guides or edit an existing one, you can certainly use this tool. So I would say really if you've got FHIR profiling needs in your organization and you don't want to, or you feel you can't use an existing HL7 published IG directly, this would be a great tool to meet your needs. We often find people, for instance, they'll take an HL7 published implementation guide, like folks from that are working with Blue Button on FHIR, for instance. So that's someone who's doing some work with that, but they're a payer, an insurance company that has their own specific requirements. They'll create a dependency on the one that was developed by the Karen Alliance, and only make the few, 3 or 4 changes that they need. So that saves them a lot of work. So instead of creating a whole new IG from scratch, you can just take something existing. In this case, I have a dependency on US core, so I don't need to restate all the US core constraints for my patient. I can just reuse that directly. So I think that's an area, basically know your requirements around FHIR, what it is you want to do, whether you're creating your own IG or working with folks at HL7 to create a new one through there. And this tool can be used with it, as can what Mark will show next, FHIR shorthand from MITRE. As Mark knows, I like FHIR shorthand a lot. I just don't get time to work on it much. But that is another thing that is on our roadmap. It just COVID pushed everything, a year and a half out. So now we're looking at that again. And FHIR shorthand is definitely something we want to integrate in here, so that either you could edit profiles as FHIR shorthand in the tool itself, or import FHIR shorthand files and run sushi and such to get full structure definitions. So we're actually very excited about FHIR shorthand. And apologies, Mark, I know you. I promised to do a lot more work on that previously. It just, like I said, pandemics happen.
Yeah, thanks so much. Let's move. Rick, if you can please stay for our roundtable discussion.
Yeah,
and
I'll stick around.
Thank you so much. Yeah, and I want to introduce our next speaker. And here it is. Let me. Yeah, so the next speaker is Nikolai. He's a founder and CTO of Health Samurai. He's behind Health Samurai 8-box FHIR backend. And also, of course, because of that, he's addressing profiling. Nikolai?
Hi, everybody. Thank you, Pavel, for introduction. Let me share my screen. Okay. So I want to do some kind of pre-announce of our new technology, which we call the then language, and how it may be applied to the FHIR. But before that, a few words about us. So we Health Samurai. So we kind of advocating FHIR in a developer's land and advocating developers in a FHIR land. So we joined the FHIR community from the early days, and we are working on 8box, which is a FHIR++ backend for what we call the FHIR first systems. So that's approach when we use FHIR not only to interface between the systems, but to put the FHIR in the heart of the system. So use the FHIR as internal informational model and use API for user interfaces. And we are applying this like more than 6 years and building some real systems, like starting from EHR, telehealth application, doing some analytic on FHIR. And that's kind of tricky way because, yeah, we definitely go beyond the FHIR borders, at least as FHIR was initially designed to exchange information. And we see a lot of value of FHIR to help developers to build the health IT systems. So we did plenty of open source and some contribution to the FHIR. And we dream about what called the model-driven systems. And so we look at into different approaches, like FHIR already have metadata like structure definition, search parameters, which can be made executable. And it's a dream of developers, executable specification. And that's how we implemented 8box. And we are working to find the elegant way to make some highly configurable system which can be configured on fly. So we considered a lot of options. So we tried to build a system on top of FHIR. We used a lot of extended JSON schema and Open API and kind of contributed this piece to the FHIR as well. Then we looked into the very interesting lang of structured how to configuration languages. One is Q by Google developers. Another is a whole, which is coming from the Haskell land. The GraphQL tried to build the same ecosystem, but eventually we decided that we should write our own language. And our dream to create a kind of foundation, the Zen language is a foundation for the model-driven systems. So you can think about the system as a set of models like FHIR structure definition, search parameters, routing for the REST API, and a bunch of interpreters. And the users may kind of build the different versions of the system using this kind of Lego style. And yeah, we definitely want to put the model information as data, not as some special DSL. And during probably this is 10 years of experiments, we come up to Zen language, and I will tell you about this Zen language. It's going to be practical. So I want to open my Emacs. Can you see my code? And just start writing the schemas and apply and try to solve the same problems what FHIR tried to solve with the profiling. When we come into the developers land, so the developers look into the profiles not only just as a documentation of something, but as executable specifications. So they want profiles be executed on the FHIR backend side, FHIR server side, and be used for the validation and other stuff like generating some SDKs and stuff like this. So, okay, and we will see how it's possible with the Zen language. So it's a kind of practical guide. So the first of all, we are using not JSON and not XML, but what's called Eden. So Eden is kind of write JSON. It's almost like JSON. Let's spend a couple of minutes to understand how, just to learn the Eden. So here we see the JSON. So the first of all, we can remove these columns. So I hope everybody familiar with the JSON. So now this is a vaulted Eden, so I can run it. So it's almost JSON. It's kind of superset of JSON. Eden has a special string to be used as a key in an object, so we call it maps. So we can replace this stuff. This string starts with a colon, and it's called keyword, and it's intended to be used as a key in a map. So, and we can remove all these commas because the comma in Eden is a space character, so something like this. So now you know the Eden, it's almost JSON plus plus. So minus some syntax and plus some additional stuff. As well, in Eden, we have, for example, the keywords may have some namespace. So name, space, key, and it's very useful. So you can have namespaced keywords. So there's more collection data types, like, for example, you have set collection, which is an unordered unique collection of some values. And you have a special string, so the keyword is a special string, and you have a special string which is called symbol. You just write it like a symbol, and this special string is used usually to refer some other entities or some other data in them. So hope you understand Eden now. So it's really simple. It's just a JSON plus. So, but it has some nice feature which allows us to build the kind of metadata engine. So, and if you have any question, you can ask just during the talk. So, okay, now we know the Eden. Now let's try to kind of write from scratch the schema for the patient. So here we have a patient. So I think you can read it. Look at this like at JSON. So we have a classical JSON representation of the FHIR patient, and we want to write the schema from scratch. So the Zen is organized as a namespaces. So namespace essentially is a map or object. Here is a keyword key, and this is a value. It has a special key which is called NS, and this is a name of the namespace. It's organized in the file system like for example, Java project do. So we use a path, the file with the same name as the name of the namespace. You can nest it into the folders. As developers, we want to keep all this configuration, all this metadata and stuff under the source control. So it's layouted in a file system by naming convention like Java or I don't know, NPM packages, something like this. So and we provide this namespace so you can put multiple models into namespace. For example, you can put the profile, some search parameter definition, so you have some freedom to organize code. And from this point of view, it's similar to the packages in Java or modules in JavaScript. So, and yeah, each model has a name. It's like a key in the map. And then this map is the body, and we call this model. So and we want to write the schema. So this is a simple schema. Text, it's a kind of type system in a Zen. So you can put multiple text, not only one type. And here we say that this model is a schema. And this schema start that we say it's very influenced by JSON schema. So we say, but with a Eden notation. So here we say that type of this schema, schema describe the map or object in JavaScript, and it has some keys. So, and we can evolve the code. Oops. Sorry, let me move it to the bottom. Okay. So here we have a data and we want to validate it. So, and we see the errors. So the engine says that it doesn't know the key name, it doesn't know the key birthday, and we don't have any schema errors. So we can kind of describe it. So the special keyword keys, and here you describe which keys this object may have, this map may have. So we say that it may have a name. For the collection types, we use a vector type. And here the special instruction which say that every element in a vector should match the following schema. So the nested is again map with the keys family and given. So now we can try it again. So we only see that the birth date is missed. So let's create the birth date, describe the birth date. Try run it again. So now we kind of recreated the FHIR profile, basic profile. That's first steps. And we definitely want to move this stuff into the separate definition of the what's called FHIR complex type. And we can do this. So let's just copy this stuff, give it a name, human name, for example, and put text. So this is a schema. And now we can reference this schema from this every with a special keyword confirms. So if we try to validate it again, oops, something wrong happened. Okay, we describe the human name. Okay, I broke my Eden. That's fine. Sorry, I will warm up and everything will be okay. So, fixed an error. Okay, let's do it again. Let's get back to the working state. Okay. Now we take this stuff and say run. Okay, now we put it as a human name. Okay. Okay, let me uncomment the working code. So here, yeah, it was because I forgot to comment. So double keys. So here we have a human name, and we can reference it. So, and you see, this is a type of this primitive is a symbol, and the symbol considered like a reference. So you can reference this symbol from here. Okay, so that works. Yeah. Now we can do kind of more FHIR-like description for the patient and try to validate it. We can try to break it, kind of make some typo, and we see that the schema says that something wrong. Hope it's clear. Any questions, or it's too strange? Okay, so now let's try to recreate the hierarchy from FHIR using, I have to uncomment the human name. So we have a type human name, which is schema, the type address, And we want to recreate the hierarchy, so we can create the schema for the resource, we can create the schema for the domain resource, and we can recreate the schema for the patient. And here on the top level, you see this confirms, which is kind of inheritance, but it's, first of all, it's multiple inheritance, so it brings more possibilities. So you can have kind of mix-ins, or what Graham called the patterns. So, and yes, and we can recreate the FHIR hierarchy. And let's try to do it now, so it works. Or if we, for example, if we command this stuff and try to run, we will see errors that resource type key unknown. Yes. So, and the same way you can do the profiling. So let's just using this confirms. You say that the my patient should confirm to the patient, and then here you see the instruction which is required of family or given, and now we can change this, validate again this new profile, and see it says that gender is required. Let's put the gender. And we see that, yeah, we mistyped this stuff. So we have kind of approached the same as value set, but as well we have very simple value set, which maybe just put into the element definition, which is called enum. So if something fixed, you can use this enum keyword to describe that just in line, that it may have only limited set of values. Okay, so you definitely don't have to write all the FHIR representation in Zen. So we have a translator, and you can just use then schemas for the FHIR, which were generated from FHIR structure definitions. Yep. So, and maybe I can show you how to do the mix-ins of the patterns. So let's say we want to extract kind of name into mixin, and let's call it, I don't know. So we can just copy this stuff and remove everything, but keep the name. So it's gonna be the pattern. And now we can remove this and add the mixin. And try to run the validation again. So it still works. So that's, for example, how you can extract FHIR patterns into the separate schemas and reuse them during the definition of resources. So we keep a lot of attention into possibility to create schemas from scratch, not starting from FHIR, because in real development, so the FHIR is not enough to build the real system, but we would like to create the custom resources which behaves like FHIR resources. They have a first-class elements. They may be referenced from FHIR resources and have reference to FHIR resources. That's why we need this flexibility, because when you're doing the FHIR first, you don't have time to wait HL7 to release the new version of the FHIR with a new resource you need. So, and you want to define it right now and start using it right now, and lately maybe align and migrate to what FHIR will release. Okay, now let's go into the profiling length. So let's play with the recreating the US core profiles. So now, as I said, so you may reuse the Zen schemas generated from the FHIR structure definition. This is just an example set. but we have a translator, so you can easily generate it for any version in a minute. And let's imagine that we have to develop the US core. So you create the namespace for the US core, give it a name. So lately, when we will export this to the IG guide, so we can use this name to generate some URLs, stuff like this. So as well, what's nice, so with in then, so you can import one module into another module. So that's how distribution works and how you can split your profiles into multiple files. And that's less than FHIR do, just flat list of files and URLs as identifiers, but more than the code in Java land, for example. So you reference the package, and then you can use everything from that package. And it's layouted on a file system the same way like usually, for example, your code do. So by convention. So let's define the patient. So we have an example of the US patient. And let's try to validate again this schema. So, and yeah, here we told that these fields are required. And here how we can define an extension. So we prefer to, at least internally or for the FHIR first system, use first class extensions. So this extension behave like first class elements in a FHIR. So you can reference it like patient.race, for example. You can put some namespace here, but it's much more convenient when you're building user interfaces, when you're doing analytic and database storing resources. But because you know that this is extension, there's a very straightforward translation from the FHIR representation of extensions and the first class extensions. Okay, so and we do this the same like we did for human name. So we just say it confirms to the race, and here is a race definition. So it's defined like a complex type, much simpler, but translator may understand it and translate to FHIR extension definition. So, but this looks more nicely for developers, less write, less support. Okay, so here how we described an extension. Let's try to validate again this extension. So this is how the first class extension will look in FHIR first application. So let's make some mistake. Okay, let's just put the typo here. And we see it's found this key. So next is the value sets. Again, everything in Zen is a model. So we can define in the same namespace the value set like this. So it can be multiple engines for the value set. Some engine may request external server. Some engine may just refer the CSV file. And here we just listed the concepts. Or here you can put just the FHIR value set definition here. And we can bind it through this special command. And it will work. So let's make mistake here. It works. Yeah, and we see that this value set is validated. Honestly, then doesn't understand FHIR value set bindings. So internally, we use the mechanism which is called effects. So you can extend then schemas with a bunch of effects. For example, you may say that the I don't know, identifier should be unique, and you can put some my extension unique. And for example, this side effect will go to the database and validate that there is no other resources with the same identifiers. And this done internally in Zen through the effects. So the validation is pure, functionally pure, but let me show you how it works. maybe it's too complicated. Okay, so it's worked somehow. If anybody will have questions, yeah, I will show you and I will tell about this. Okay, so that requires smart enough. So for example, here you can say that or given or family, and what else we can do? Yeah, we go through the value sets, we go through the extension. Now let's go to more classical profiling examples like BMI, for example. Let me show you the BMI in Eden. And this is analog of the US core BMI. So when you will do the FHIR profiling for the BMI, you will probably use slicing and all this stuff. But in Zen, we have a very interesting keyword, which is called match. It's a kind of pattern matching. So you can say in one command that this resource should match this pattern, this template. And all validation will be done automatically. So we just skipping this complicated area, which is called slicing, by very simple to understand pattern matching stuff. So here in pattern matching, this we don't put here as a vector, but we put the set notation, which means find in the coding collection something which is matched by this pattern. So let's try to evaluate this stuff. So we can run validation against FHIR observation, basic profile, or we can run against the BMI. So, and we see that we have a mistake, like here should be quadratic stuff, or we can, for example, mistype here. And we see it's validated by the match command, and it gives the path of the problem. And this is a path to the schema which validate the source of the rules. Okay, any questions? Let's go further. So still, eventually we need some slicing stuff. And this looks kind of mysterious, slicing in FHIR. And in Zen, we simplified it a lot. So because the slicing, so now I will try to explain this kind of complicated FHIR concept in a very simple words. So you need slicing when you have a collection of something and you want to put some constraints or apply some schema or other extension to the elements of this collection, but not to all of these elements, but to some of elements. And it's equivalent to the following, the model that you filter collection by some criteria, and then you apply some schema or extensions to elements which were successfully filtered by this filter. So here is a special word filter, and we see the hash map. These keys are just names for the filter results. And we filter by matching, again, the pattern matching, so which may be simplified, but you may filter by other stuff. And we apply this schema to the items which were filtered. So here we say that the component should have exactly 2 items, min and max. And then we are filtering some code, allowing code for this systolic stuff and applying this schema. Internally, we're matching that the quantity units are right and put, for example, some other stuff like other validation constraint that the number should be, or even maybe more, something like this. So hope this is clear. And then you do another filter and apply another schema. So let's try to run it. And we see that we have a problem with the units. And we see that this is a diastolic slice of the filter. So, and you can easily put more constraints or even add the extension to the specific slice. Let's say we want to add here the special extension. If we will comment it, for example, for the systolic stuff, okay, and we will try to put here this strange field and try to validate it, we will get an error that I don't know this key, but we can add extension here and try to run it again. And now this problem disappear. And let's fix the last problem as well. Okay, got, so we passed this stuff. Okay, so that's, I think, essentially all. Here you can see how compact this stuff, and it's very flexible and it's extendable when you're building the system. So you gotta add more effects. You can reformulate this, making some mix-ins, patterns, and you can easily reuse it by importing the namespace and referencing stuff. So hope at least something is clear. Any question about this?
Yeah, thank you, Nikolai. There is one question from Chris. Is there a tool to convert your Zen schemas into FHIR structure definition so that other tools in the FHIR ecosystem can understand them?
Yeah, that's what we are working on. So we already built similar tools. So before then we built what's called IGPOP. It was a YAML-based data DSL. And we implemented the conversion from the data DSL to the structure definition in FHIR. Because Zen is more powerful, probably not all aspects may be converted to the FHIR, but we are working on this, and I think in a couple of months you will see it. So, and the Zen and all these converters gonna be the open source. So they are already open source. So, and we have for previous version, which is called IGPOP, we had a very nice IG guide generator, the static page generator. So, and we will enhance Zen as well with such type of generator. So if you're interested in this, so please contact us. And it's an early stage for Zen. It's like a third version, the third attempt to do it aesthetic as we see it, as the developers may use. So you build this. We're already using it internally for more than a year. So it's kind of internally matrix, but we have to pack it and for the open source and make some tooling around. Okay, so now maybe let's get back why we're doing all of this, why we invented our own language, because at the end, what we want to provide, it's a Lego to build your FHIR backend. So we want to give the user the full control over the FHIR server. So every aspect may be configured here, just a imaginary configuration. So the idea that you're getting the empty FHIR server and then using this set of data DSLs, you're configuring the routing, what operation available, what access policies. So you do the configuration instead of writing code. And we're providing a lot of interpreters and eventually different engines, for example, for the FHIR search. Some may be efficient, some may be kind of support partitioning and stuff like this. So that's our goal. And we are moving to the third version of 8box, which is going to be completely configurable. So that's everything from my side. Hope at least something will be clear. Any other questions?
Thanks, Nikolai.
I would appreciate any feedback. If it looks too complicated, or that would be nice. If you have similar ideas, yeah, please contact me. If you enter then link on GitHub, you will find this open source project.
Yeah, we are short on time, so
Thank
let's keep it for roundtable. So thank you so much, and let me introduce our third and last speaker for today. So we have Mark Kramer from Mitre, and Mark has already started sharing his screen, so I'm not going to show his picture. So Mark, it's all yours. Please introduce yourself.
Thank you, Pavel, and once again, thank you to Health Samurai. I appreciate it, and Nikolai. I have very fond memories of ice skating with you, playing hockey against those Dutch boys in the dev days in Amsterdam. So good to see you again. So I and my colleague Chris Moselle are both from MITRE. MITRE is an unusual company. I don't know whether you're familiar with it, but it's a not-for-profit in the US that works for the US government for the most part, but we also do public-private partnerships, and we work in a very mission-driven way for the health and safety of US residents. So of course, we're also concerned with those overseas. So a lot of us are very mission-driven, and FHIR and interoperability is very important to the future of the healthcare system, we believe. So we've contributed over the last at least 10, 12 years to the whole subject of digitization of the health infrastructure. So FHIR shorthand is one small piece of that. What I'm going to do is talk through what FHIR shorthand is. We call it FISH for short, FSH. Going to talk about the language itself and how you author with it, then how you build an IG. I'll hand it over to Chris. Chris is our lead developer, and he'll do some demos of how you build an IG from start to finish with FHIR shorthand. So since we're short on time, let me push forward. Go ahead. So we're already on the background. So let me give you a little bit of background. I mean, the good news is that we have many, as a community, we have many different ways to do profiling. And you can pick a tool that suits your needs and your skills and your aesthetics. So I think in the beginning, all we had was hand editing of structured definitions and value set resources and code system resources. So fortunately, Lantana came along and created Trifolia. Forge is a product from our friends at Firely, who run the Dev Days meetings. And, I consider those to be kind of guided ways to create profiles. So they're very good if you like, interacting with a tool in that way. What I'm going to talk about is, I would call it command-driven. It all originated from kind of frustration with the spreadsheet methodology, which was how we were doing things, 5 years ago, since denigrated or deprecated. And it was very difficult, very not obvious. So I just really wanted to say what I wanted to say, constrain this cardinality to 0, 1 or 1, 1, and make it happen. So I talked to Chris and he made it happen. So thank you to Chris for making my dreams come true. So I'll explain, about how this works in a minute, but briefly, FHIR shorthand is a domain-specific language. It's designed for saying the things you need to say when you do profiling. And since it's designed for purpose, it's concise, it's readable, and it's understandable. So you can pretty much look at a little bit of FHIR shorthand and get even if you don't know the language, you can get the idea of what it's trying to do. The other thing about having it as a language is that global changes and finding stuff is really easy because you load it up in a development environment. We use Visual Studio Code mostly, but you could use Notepad++ or whatever. And you can search for stuff. You can replace, if you want to rename something, you just do a global replace. It's very easy. The other benefit of text is that it's really ideal for source code control. So you can put it under GitHub, and then it takes care of all the versioning. You can branch off, you can do some development, you can remerge it, you can do PR, pull requests, you can different branches or forks, and it's great for cooperative development. In fact, this is an open source tool, it's free, and we've had contributions from the outside. In fact, thank you. Rick Geimer has made a few contributions. I appreciate that, Rick. And we've recently had contributions from Athena Health, who gave us a developer for a couple of months full time to do a new feature which allows you to do logical models in FHIR shorthand. So it's kind of a coding, compiling, and output kind of paradigm. And the compiler does a lot of error checking. It also applies some best practices, so you get structure definitions out that do things sort of the mainline best practice way. FHIR does everything that you can do if you are manually editing. So it does profiles and extensions and value sets, code systems, and variance mappings. And now it does also resources and logical models. The last thing I want to say that's important is that it's the language itself we've introduced as a standard through HL7. And it's integrated with the FHIR IG publisher so that when you run the publisher, it detects if your project has FHIR files, and it'll just incorporate them into the IG. And you'll see that when Chris is working, does a demo. Next slide. So it's turned out that this has been pretty popular. I don't know whether we're bigger, smaller, or equal to Lantana. It really doesn't matter. But we've had a lot of downloads of our software. You can see here the trends of downloads per week. You know, this doesn't mean we have 45,000 users. It just means that when we have a new version, people download the software or experiment with it. But it seems to be quite popular. Next slide. And next slide, please. Yeah, so we also have this tool called FHIR Finder, which goes around and crawls through GitHub and finds projects that are using FHIR shorthand. And there's quite a number of them. We just got up to about 140. This is a little bit older. And they're all over the world. There are people developing IGs, New Zealand, Switzerland, Belgium, Denmark, et cetera. WHO, the Da Vinci Accelerator. We've done COVID-oriented IGs with Saner and Logica. Blue Button, which is something in the US that helps consumers download their software. And recently we've done a vaccine credential IG, which gives a QR code on your phone that shows that you've been vaccinated. So it's only been out for a little bit over a year, probably 15 months now. And the uptake has been really good. So I think we've hit a nerve or we found something where people really enjoy using it, and we try and make it fun. There's an active discussion groups on Zulip and all that. So it's kind of a nice community. Next slide, please. So let me dive into what this language looks like. And again, I'm going to show you some syntax. I'm going to use a coding playground that we've put together, which is under fishschool.org. So if you go to fishschool.org and you click on Play with Fish, you'll get to our fish code playground. And this is not how you would necessarily do a full-scale application of FHIR shorthand, but it allows you to get comfortable with the language. It also allows you to share examples with others for the purposes of teaching or the purposes of debugging. And in fact, I'm going to give you a URL here, bit.ly 3Y capital P capital A H35. That encompasses an example that I'm going to do. And if you type in the 3Y capital P capital A H35, you'll load up our coding playground, which we affectionately call Fish Online. So I'm going to do this intuitively because there's too much in the language to go through in 30 minutes. But this is how you would begin to do a profile. Here we're profiling condition, and I'll use a fake COVID-19 example. Everyone has to do a COVID-19 example now. So we'll do reporting a COVID diagnosis. So we start with a keyword. So you open up your favorite text editor first. In this case, we're in the code playground. You type in a keyword, profile, and you name your profile, in this case, COVID diagnosis. And every profile inherits from a parent. In this case, we're just inheriting from condition, but FHIR shorthand allows you to inherit from other IGs. So you could build on US core or New Zealand core or Australia core, whatever you like. And then you can specify a description field. So here it's how to report COVID. Now, following that, there's a set of rules. So when you see these asterisks, it's like a list of rules. It's just sort of like markdown rules, kind of. We're assigning a code. So the code attribute of the condition, we're assigning to ICD-10, and the code is U07.1. And you'll see this funny $sign, and then down at the last line of this example, you see that that's an alias. So that's optional, but to avoid writing out that long URL, we assign this alias, and we can use it many times throughout the source code. The second line, we're binding a value set to severity. So COVID severities, we won't use the default, but we'll create our own value set, which I'll define in the next slide, the COVID severity value set, and we'll make it required. The next, we'll restrict the subject to a reference to a patient using a rule involving the word only. And you see the highlighting here comes from the coding playground. You can also do this on the desktop because we have a plugin for VS Code that will highlight the special characters or the special keywords within your fish. And finally, we are going to take subject and make it required. So 1.1, and you'll recognize this from the way that FHIR presents the cardinality within a IG. So now we've defined a profile. And there's actually a pattern here where every item, and you can do code systems and extensions and all those things on the left, I won't recite them, all follow a pattern of having a declaration first, then a set of keywords, and then a set of rules. So if you just keep that in mind, that's the anatomy of any fish item. And the set of keywords that follow the declaration, and to some extent the set of rules you can use, depends on what you're defining. Next slide, please. So let's go and define this value set, the severity value set. When you look at FHIR, it actually has a value set called condition severity, and it has severe, moderate, and mild. But let's suppose we want to add something called life-threatening, because if you're on a ventilator, that might be the way that that's reported as even more than severe. So we start with a keyword value set. We give it a name, COVID severity VS, a description, and then we have a statement in our language that goes include codes from value set. We give the name of that value set, the URL of that value set. And we're going to add another code. So we say include, and There's an alias for SNOMED, and then code 442452003, which is life-threatening severity. So there we're done with actually defining that value set in 4 lines plus that alias, and the alias is something that's optional. That's pretty simple, but you have to know, you have to get comfortable with the syntax here, because off the top of your head, you'd never guess, that's the syntax. What's very interesting about the playground is that you can find some examples that show you how to do things. And also, if you go to FHIR, you can go to any one of those GitHub repositories and you can see how other people have done things. And if there are 100 plus projects, you can pretty much find anything. Next slide. Thanks, Chris. So next thing you want to do is create an example of your profile. As Rick said, this is required by HL7, so otherwise the publisher complains. So you use a keyword instance. So here's our diagnosis example. It's an instance of that profile we just wrote, the COVID diagnosis. The subject, we're going to reference another instance, Jane Doe. We're going to set the code to the appropriate code for COVID. And we'll set the severity in the case of Jane Doe. She's serious, but she doesn't have life-threatening COVID. And of course, we need to make Jane Doe herself. It's an instance of patient, and we'll just give her a family name and a given name for now and call it quits. So next slide. So now if we're in this code playground, Fish Online, we can just hit that. So the code that we wrote is on the left. If you haven't loaded it, that's what it looks like when it's on the left. And then you click that convert to JSON button, and boom, on the right-hand side, then you'll see the resulting JSON structure definitions, value sets, and instances. And they're actually in different windows, and far right, you can click on those to see the generated JSON. So that gives you an idea of what pops out of the fish language. And if there are any errors, you can see at the very bottom here, it says console success. It'll give you a red X down at the bottom if there's any errors, and it'll point to the line which it's questioning. Next slide. The other thing, and I've mentioned this briefly, is that there's a new button that's just been added, which you can see at the top left, fish examples. And it gives you some examples of how to do things. And you can see all the different, the sort of menu there. It pops up a dialogue, and you can clip that text out and use it as sort of your seed for building up your own FHIR shorthand. So we hope that that's a great on-ramp for you to begin to use use FHIR shorthand. We also have documentation that has a tutorial that's really worth doing, and we'll show you that at the very end when we point to the resources. But with that, I'm going to turn it over to Chris, and he's going to take you through a demo.
All right,
Chris,
great.
Over to you.
Thank you. Hopefully you can hear me okay. My name is Chris Moselle. I'm a software engineer at the MITRE Corporation, and I'm just going to quickly walk you through how do we actually take what Mark just taught us about the FHIR shorthand language and use it to actually create an implementation guide. How do we get down to the practical bits that are required? So there's basically 6 steps, and I'm going to walk you through these steps one by one. The first step is to install Sushi. So Sushi is a compiler that can take that FHIR shorthand language and compile it down to formal FHIR structure definitions and other FHIR resources. Sushi is actually a self-referential acronym. It stands for Sushi Unshortens Shorthand Inputs. And if I recall, I think Rick Geimer may have been the one who actually came up with that acronym. If he's not, I've been giving him credit for a while. Yes, I thought so. So
I remember that meeting.
Yeah, cheers to Rick, because we love it. But Sushi is based on Node.js, and so you need to install Node in order for this to work. But after that, you can install it very simply by saying npm install -g fish sushi. If you have any questions or need more help, you can check out Fish School, and there's some documentation there. As Mark mentioned, we also have Visual Studio Code and a particular plugin for that adds syntax highlighting and some other features that I'll show you too. So that's also a highly recommended component. And now let's actually just jump right into some demo where I'll show you the rest. There are slides that also reflect what I'm going through in the demo if you just look at the slides later on. But we're going to be doing everything here live now. So when you want to create a sushi project, one way you can do it is by using sushi init. And what that's going to do is set up a baseline project for you. It'll ask you a few questions like, what do you actually want to make your project about? So we can say like, okay, this is our COVID IG. And we can say our example, our ID for our project is FHIR.COVID. Our canonical is, well, I'm just going to accept the default for now because it takes time. Default status, default version, and then it just says, okay, do you want me to create this thing? And we'll say, yes, please do. So we'll go into the folder that it just created for us, and let's take a look at what we have there. I'm going to open Visual Studio Code to actually look at this project. I'll bump up the font just a little bit. On the left-hand side, you can see this is the project that was just created by Sushi. It has some scripts for running the IG publisher. It has a git ignore file if you're going to be using GitHub with this, an IG INI file, which is required by the IG publisher, and a configuration file. So if we look at this configuration file, this uses YAML to be able to provide your configuration information. It contains a lot of the info we entered as we were doing the sushi initialize process. There are some other things. If you go to Fish School, there's actually documentation about all of the different parameters that you can define here, including things like dependencies on other IGs and things like that. And we also have a way to define your menu system down here as well. So that was generated for us. What was also generated for us was this file here called patient.fish. This is a very simple file, just so there's something there, but ideally, you would probably get rid of this and start writing your own thing. You might want to name your file something else. You can split up fish definitions over multiple files, put them in nested folders. You can organize it however you want. One of the features that we have in VS Code is what we call snippets. Actually, VS Code calls them snippets. And if I start writing a few letters of a keyword like profile, you can see that this thing popped up and I can click enter and it fills out some of the templating information that we need when we are writing a profile. I can actually do something like, my condition profile. And you can see as I'm doing that, it's actually filling out other fields too. When I hit tab, it's actually going to apply some best practices there, and it's going to convert my ID to all lowercase, use dashes between words. It's going to create a title for me that has spaces and is human readable. So that makes it a little bit quicker for me. I can say this is going to be based on condition. I could put in a description if I wanted to, and then I can get down to the rules. So kind of a nice little feature, and it's all the major FHIR shorthand entities are supported in this way. Another thing I'll show you is when I am actually defining something like a profile on condition, it's really helpful to see what is the definition of condition in FHIR. So I can right click on this, say open FHIR documentation. It's going to open up my browser to the condition resource. So now I can kind of look at this and use that as I write out my rules, and it can be very helpful. But what we're going to do now is we're actually going to follow that same example that Mark was using, and we're just going to put that information in here. So here's our COVID diagnosis, and I'll show you one other feature that is in here is if you right click on a word that you've defined in your FHIR shorthand somewhere else in the project, either in this file or in another file, you can say go to definition, and it'll automatically scroll to the definition of that item. So that can be very helpful for quickly navigating between things. And you can also hold down a key. On Apple, it's the command key. On Windows, it's something else. But if you hold it down and hover, it also shows you just a brief glimpse of what you're looking at, which can also be helpful as you're authoring. So now we have our IG. That's it. We actually have an IG that's ready to be published. So we can go over here and I'm going to just run sushi on this folder. And it's going to run through those definitions, compile them. If I had any errors, it would report them. But luckily, everything turned green. We can see that we've generated a profile, an extension, a couple of value sets, a couple instances. And we also get this nice fish pun, cool and so fish-dicated. Every time you actually run sushi, it's going to give you a random pun. And the pun will be based on how many errors or warnings you have. So we get nice happy puns when things are happy, and we get darker puns when things are not so happy. So now that we have done that, we actually can go ahead and run the publisher. Usually I'd run a script that would download the publisher, but we actually, that takes time. So I'm just gonna copy the publisher here. Oh, actually I need to make a directory called input cache. And this is actually defined by the IG publishing framework where a lot of these things go. And I'm going to copy the publisher jar to input cache. And now I'm going to run the gen once script. And this is actually running the IG publisher on what we just created. So we're going from scratch to an IG here. And as Rick showed in his demonstration, this takes a little time, but it's generally, if you have a smaller IG like this, you're talking about a minute or less. So I think this should be ready in just a minute here. Creating the HTML, and there, it's done. So now we can open the generated index file that it created, and we have our IG. We're using the base template here, but you can specify what template you want in your IG INI file. And we can go to our artifact listing here, and I'll make this bigger, but we can see those things that we defined in FHIR shorthand. We can click on that. We see our differential. We see our snapshot. So you can see we went from scratch to having this full IG pretty quickly. And really, this is the only code that we actually had to write here. And you can see, as Mark showed you, it's pretty straightforward and declarative regarding what you're doing. So that's pretty neat. So I'm going to go back to my slides here for a minute and jump through those things we just demoed. At this point, you can add more fish. You can add some narrative content so that you can actually have your IG looking like a real IG with pages and descriptions on the individual resource pages and things like that. You can customize your menus. You can create a GitHub repository and share this with other people. So this is basically how you can start from scratch. But what if there is some existing FHIR that you're interested in, and do you want to see how would that look like using FHIR shorthand? Well, good news, there are ways to do that as well. And we're going to go back to Fish Online here. And you'll notice that there is a left-hand side and a right-hand side. I'm going to just reload this from scratch so that they're both blank. And here is a structure definition for, here's the body height profile from FHIR R4. If I click on JSON, I can actually see the JSON structure definition representation. I'm just going to copy that. And I'm going to bring it over here in Fish Online. So here we have our structure definition, and you can see there's quite a long differential here that describes the body height structure definition profile. I can click on Convert to Fish. And over here, we got out the FHIR shorthand. Now you'll notice this is fairly wordy. Part of that is because of the way that this particular profile is built. We do have a number of extensions that we are looking at. We do have some slicing. And then the way that they happened to fix the codes, they went through a fairly verbose approach to doing that. I would actually use a pattern, which would actually reduce all of these lines into just one line of code. But this is actually representing the profile exactly as it was in the structure definition, only using FHIR shorthand to do it. And there are a few things here that you haven't seen before that I'll just quickly call out. One is this index format. We use something called soft indexing. And what it is you can use numeric indexes when you're talking about items in a list. but sometimes that can get a little cumbersome. So often we'll just start a list with 0 and then use equal to say use the same index as the last one, or plus to say increment the index from the last one. So here we've got 0, 0. This is 1, 1. We increment again. So this would be 2, 2, etc. Another thing that you see here is all of these start with a caret sign. So for example, publisher, this is how we can directly set information in the structure definition resource itself. So structure definition resource defines an element called publisher. This is how we can get at that publisher element to directly set it. So of course, we can go ahead and round trip this, and it's going to take this FHIR shorthand, and it's going to create this over here. Now, what if I wanted to do that actually in aggregate over an entire IG? Well, you can also do that. And I'm not going to show you exactly how that works, but we have this thing called GoFish. And with GoFish, you can download an existing IG. You can expand usually it's like a tarball or a zip. You expand it, and then you run GoFish on it. And it will actually try to convert the whole IG into FHIR shorthand resources. And I have done that with US Core. And I can just quickly show you what that looks like. Let me go back one directory. So this is US Core. There are multiple ways you can tell GoFish to format the output. I have it formatting by type. And so all the profiles are in one page, but you can see here, just go to the top. Here's our profile for US Core Pediatric Head Occipitable Frontal Circumference Percentile Profile. I think I saw Eric on the call. Thank you very much, Eric, for this profile name. I really appreciate it. It makes all of my presentations just like 5 seconds longer than they probably needed to be. But anyway, so we have this profile, and again, it's a parent of US Core. And if I wanted to see, oh, what is that definition? I can say go to definition, and here's the US Core Vital Signs profile as well. So a way to jumpstart your IG using FHIR shorthand if you have an existing one. So we very quickly took you through some of the tools: Sushi, GoFish, VS Code, Fish Online. Mark showed you Fish Finder, and then Fish School is where you can go to find out information about all of these things. The FHIR shorthand is an HL7 specification. You can actually go to the language reference, and we have a URL here that goes to the latest build, which has some of the newer FHIR shorthand features we've been working on. We also have a quick reference card that you can use, and this hasn't been updated for shorthand STU2 yet, because that hasn't even validated, but this has all the FHIR shorthand 1.0 stuff in it as well. We have a set of relevant links that you can take a look at later if you'd like, and I think that's it. So we can open it up for questions.
Thank you, Chris. Thank you, Mark. Please, everyone, be more active. So we have the first question from Nikolai. So can fish be used to define basic FHIR profiles or custom resources? Did you think about this? Mm-hmm.
Yes, so FHIR shorthand can be used to do profiles on basic. You certainly can do that. And when you profile basic, you're primarily working with extensions, but we did try to make extensions so that they're pretty easy to use and fairly straightforward. But you can also, as of maybe a month ago, we do now support creating custom resources. So you can create resources that have first-class elements that are brand new, and that works as well. There are some caveats there as far as the rest of the FHIR tooling goes. The IG publisher and a lot of the other FHIR tooling really is built around the concept that only HL7 creates resources. And so if you try to use custom resources with a lot of that tooling, it won't work, but we will actually generate the structure definitions for those custom resources for you. So if you have your own internal kind of ecosystem or framework that knows how to work with your custom resources, then you can use FHIR shorthand to define them. and that's in the that's supported in the Sushi 2.0 beta release. It's not in the official release yet, but we expect to release that as an official release in the next week or two.
Thank you. More questions? Anyone?
Yeah, I can ask this way. I think it's simpler. Right? Thank
Yeah.
you. Amazing. Yeah, I remember just like 1 year and we have an amazing tool. Do you have any syntax completion and checks in Visual Code? Like I start typing some keyword and it autocomplete, or if I mistyped, it will show me error in Visual Code. Or
right. We don't have that yet. That is something we would like to build. Certainly, once you start typing and you, for example, declare who your parent is on a profile, then we'd love to be able to have it so that when you're writing your rules, it will actually tell you, these are the valid elements in that profile. So for example, if I have done something like observation, then when I go to write my rules, if I start typing C, it might say, give me a choice between code and, some other element that starts with C. So we want to support those sorts of things. Yeah, in component. Yeah. So we want to support those things. They're not there yet, but certainly VS Code obviously has what's needed to be able to make that happen. We just haven't gotten around to it yet. And the same thing for being able to provide some error checking and like underline something that's wrong. So we'd like to do that too. There are some more limitations regarding exactly how much we can do there and still remain performant, but I think we can do some things there.
Mm-hmm. Thank you. Any way to add some extensions to Sushi, like macro or something like this? So if I don't want to kind of print the same pattern again and again, so can I add the new rules to the Sushi?
Yeah, so one of the features that we didn't have time to go into is sort of like a macro. We call it rule sets. And rule sets enable you to, if I understand your question correctly, so there are repeated, needs to repeat some statements. And sometimes the statements you need to repeat, they're the same except for some argument, like the name or, so we have this very powerful feature where you can define this sort of macro, which expands into a set of rules that, can be specialized to where you're inserting them. So I think, let's see, Chris is showing the example for a capability statement. And capability statements, you can spend a long time writing because they are long, they can be lengthy. So here is a set of rules that says, one rule set says support resource, and it has an argument resource and expectation. The expectation is should, shall, or must. And so you can just say support in your definition of the profile for the capability statement. It's not a profile, it's an instance. You just say support this resource, support this profile, support this interaction, support this search parameter, and it becomes much more readable than before and truly lives up to the shorthand part of FHIR shorthand, because you're saving many statements that you'd have to write if you were doing it in JSON or in XML. It's a feature that I love to use, and I use it a lot. And it's a more recent feature, so not everyone that's using shorthand is doing it, but it's one of the most powerful things actually in FHIR shorthand.
Thank you.
There is a question from YouTube chat. Ilya Beda is asking, why do you end up with custom syntax and language? You may use some dated DSL, something like a more simple version of structure definition resource.
So, it's interesting because we looked for a long time at YAML. And why did we actually come up with the DSL of our own? Could you just like define your profile in some sort of declarative way? And I think you could do that. We did do a pretty thorough evaluation of alternatives. And it turned out that, you know, FHIR is different enough, I guess, where it just made sense to create this language that was more directly readable and resonated with FHIR users. I remember having quite a long discussion with Eric Haas, for example. He's a primary author of US Core about this very subject. And you know, if it's not your cup of tea, then, you know, you can decide to go a different way. And, you know, I think Rick has shown a very viable methodology of using, you know, Lantana. But there's a certain type of person that's very comfortable with learning this kind of language, and I think it applies pretty well.
Yeah, Mark, this is Rick. I hope you don't mind if I chime in here. As I've had conversations with you before, you know, I like our Lantana tooling. I like the GUI because I think it's useful for people who don't have that coding mindset, but myself, I do. So sometimes I find our own tool somewhat hindersome because I want to be able to export everything, edit the text, and then put it back in and use it more of as an organizing principle. So I really love FHIR shorthand. I think you did pick the right syntax. I'm not a fan of YAML for something like this. I think you made the right choice.
Thank you. Very kind.
So this is kind of markdown for the FHIR. Yes?
I noticed some questions about CQL, and I've got to give that over to Chris because he's one of the primary authors of CQL.
Okay.
Are you looking at chat?
I can be.
I'll read it to you. Let's see. What about CQL engine? Is it able to evaluate custom resources?
Okay. Yeah. Yeah. So CQL execution and CQL FHIR exec. Yeah, I'm also one of the primary developers of those open source CQL execution engines, and the short answer is it depends. So CQL is defined to be data model agnostic. And so you can hook up any data model to CQL. Most of us are using FHIR with CQL, and there are formally defined FHIR data models for CQL. They're defined in files called model info files. And those model info files define the full set of all FHIR types that comprise FHIR, right? So if you wanted to use CQL with custom resources, you would actually need to create your own extended data model that maybe includes the FHIR stuff, but also includes all of your custom resources. And those would have to be represented in this special model info format in order for CQL to FHIR CQL to ELM, the translator, to be able to translate them properly. And then in order for CQL execution to be able to actually execute on them, you would also need to update CQL FHIR exec so that it uses those FHIR model info files as well. So there's some additional things that you need to do, but the overall framework and architecture for CQL execution and CQL exec FHIR do allow for it.
Yeah, I think, by the way, Chris has made such a huge contribution. I have to pat him on the back for being the genius behind both at least half the genius. Bryn Rhodes, has done a great deal of work on CQL, but with CQL and FHIR shorthand, Chris has really distinguished himself in this community. And again, these are all open source and free. So that's another thing that, you know, we can always take contributions from the outside, and we're very, very happy as working in the public interest to provide these tools free of charge.
Yeah, I think this is very well in line with FHIR itself, and we have seen 3 solutions today, and all of them are open source. That's very exciting. I submitted a link to provide the feedback about the FHIR meetup. Also, yeah, let's try to wrap it up maybe with some discussion if anybody wants to join. Like as you know, don't have to maybe type, maybe just open your microphone and speak. And yeah, so let's try to talk about what you have seen. Maybe any feedback you know you can give right now. Any questions to speakers? Anything we have missed? Who can start?
Yeah, I would like to ask the question to Mark and Rick and Chris. So what was the most complicated piece in implementing this tool? I mean, in profiling, in FHIR profiling. What was the most challenging piece to implement?
Well, I'll go first. For us at Lantana, it was always slicing, because you've got a lot of complexity, you know, just defining a slicing, getting your discriminators correctly. And then when you've got a profile that uses slicing and you want to derive something from it, you've got additional complexities about reslicing or redefining an existing slice, where you don't actually change the discriminator, but maybe you want to make something that was a optional slice required. And you know, the documentation around that isn't really very good, and you kind of have to figure out how to do it yourself, often by making, you know, dozens of mistakes until you find out what works. And you know, again, reslicing is its own mythical beast. I'm not sure even that anyone fully understands how that should work properly, but we have gotten it to work. We just don't know if it's actually the way it was intended to work. So I'll hand off to Mark for his thoughts on.
Well, I'll hand off to Chris because he's the implementer. I just say make it so, and Chris says, "What do you mean make it so?" And I say, "Go check your memes."
Yeah, so I'd agree with Rick that slicing is definitely a challenge, and to some extent, I mean, we definitely do support slicing, and we support reslicing and all those things. I think some of the complexity there we have passed down to our authors. We've basically given them the tools they need to do slicing, but some of the really tough spots are still things that authors just need to kind of understand a little bit about
their own throats,
right?
If they're not careful.
Yeah. So I'd say that's definitely a challenge. I think for us, a lot of the challenge is that although there are many aspects of FHIR that are specified quite well, when you go to implement something like a tool that's going to generate profiles and structure definitions and things like that, you discover all the things that aren't documented so well. When you actually need to make it so, you realize like, oh, that, you know, the FHIR specification actually doesn't describe how you make it so. And so then you end up having to look for examples of existing profiles, or look in the IG publisher source code, or oftentimes just ask Graham or Lloyd. So for us, I think a lot of the challenge has just been trying to eke out those parts of the spec that maybe aren't as robust as they could be, and figuring out what to do there. Like one example, there are many examples, but one example is that when you are creating differentials in a profile on something that, well, not even differentials, but when you're doing a profile on something and you are working with a field that is essentially an array, it has multiple cardinality, depending on the field, if you specify an array in the differential, that array will either completely overwrite the original array, or it will actually append the original array. But the specification doesn't actually tell you which fields do what. You just have to kind of ask around or figure it out. And that is something that actually we raised and they are now addressing, and they're going to try to make that more explicit in the specification. But that's one example of something where we really had to kind of scratch our heads a bit to figure things out and learn some things by trial and error.
Yeah, thank you. So I'm still curious. Maybe the slicing is overcomplicated. That's feeling that's with me like during the 5 years. I don't know why. Probably we can fix it on the FHIR side. I don't know. Have you think about this?
Yeah, it goes back to a very early discussion and argument that we had about how to extend FHIR. And of course, the idea that you would have a fixed schema and just populate an array as a way to create extensions actually sprung from limitations of XML schema, which has long since been a non-issue since most of us are using JSON. So we had, this is back in 2014. Some of this has, even before 2014, we started in 2012, 2011, 2013. Yeah, some of this has a long history, but we ended up with this idea of, there are no subclasses, which is also very interesting, right? You just have profiles, the profiles are really just validators. They aren't subclasses. So there's a subtle difference there because, everything is an observation that's, that descends from observation. All these profiles we're making, that represent a type of lab or a type of clinical result. They're really just the class's observation. And all we're doing is we're populating arrays in different ways. And then we have a validator. The profile is a validator that sees if you do that correctly. So it's a really strange architecture. It's not obvious that that's, the only way to achieve interoperability. There could be other, subclassing ways to do it that may make more sense, where you can add a full, instead of adding an attribute, we're slicing the extension array, which is really an odd way to do it when you think about it. But that's, I don't think we have much chance to go back at this point and rethink that decision.
We have thought about, like with FHIR shorthand, are there ways that maybe we can look at a pattern and infer that it should be sliced? So for example, if we see that somebody set up a component and then fixed the component.code multiple times for multiple things, then can we infer like, oh, they mean to slice and figure out what all the slicing details should be for them? We called that Jinzu slicing or Ginzu slicing, but we haven't gotten around to doing that. I don't know if we ever will. But there certainly are a lot of slicing patterns that show up again and again and again. And I think one question would be, can we leverage that and say like, okay, can we at least make it easier for the 80% of the times that you're using, one of 3 slicing patterns?
I'll give you an example.
Can we make that easier?
I'll give you an example. Like if you go to the examples in our code playground, Fish Online, like you want to slice observation.component. It's very, very common to do that because you'll need more than one component, and there's a rule set. I mentioned that earlier in response to one of Nikolai's questions, these rule sets. So instead of trying to figure that out, which requires some FHIR superpowers, you can use an existing rule set that someone else wrote to figure out, okay, this is the standard way to slice observation.component. And we have those slicing rules for different common cases. Another one is on report, where you want to slice and have references to different observations in a diagnostic report, for example. That's a rule set that we have. So instead of trying to read the user's mind, we provide some patterns that can be repeated.
Yeah, and one other thing that quickly comes to mind, and this is just a tiny thing, but for those of you familiar with the details of slicing, there is basically a way that you can say what type of slicing you want to do, how you want to discriminate, and it's a discriminator type, and there's multiple values that are allowed there. But one thing that the FHIR community realized in the last year or so was that two of those values, pattern and value, really are essentially the same thing and don't need to be distinguished. And so one of the things I think that they're looking into for FHIR R5 is actually reducing that set so that there's no longer pattern in value, but it's just one of those. I think it's just pattern, just value. And so that at least simplifies it by reducing the choice a little bit more. But aside from little things like that, yeah, it's probably too set in stone to make major changes to how it's done in structure definition, which means now we're having to work at the tools above structure definition to try to simplify it for the user.
Any other thoughts, questions?
Well, I'd ask Nikolai, what did you find most challenging in your experience, having to write structure definitions with your previous framework?
Yeah, we have many frameworks. So we initially started from just interpreting the structure definition on our side. Then we tried to translate everything to JSON schema. It was kind of challenging. So we had to extend JSON schema. So we wanted to support the Open API and FHIR both. And now, yes, we came to this custom DSL because we have a lot of other DSLs. And for me, it was always curious that sometimes you have some complicated pieces on FHIR, which looks kind of overcomplicated. For example, the slicing used a lot for different pure protos, yes, to define extensions. But for extensions, for example, we use first-class extensions. So internally, the race is represented as an attribute. And we have a converter when we try to be compliant to FHIR. So we're converting on fly the, for example, race attribute to the race extension. So internally, we have just element race. And these converters was kind of complicated because it's the next layer. Yes, you have FHIR, you have your own model, and you have to translate between these pieces. What else? I don't know. Yeah, the value sets, it's another challenging. When you're trying to implement the value set validation in real production system, it's a challenge. Because the value set, it's a rule, it's an algorithm, how you build the value set. And it's kind of hard to make it efficient. I mean, validation, because in real life, a lot of data inserted and you have to test it, check it through the profiles. So that was another challenge, and implementing the terminology as well. Yeah. Implementing search, but this is not the subject of this talk, but the search and FHIR is like, I think is like slicing and profiling when you try to implement it.
Yeah, I was part of a team that wrote a FHIR server in Golang, and I was in charge of implementing search. And yeah, you can make it work, but it's making it work efficiently that's really hard.
Yeah. And there's a lot of undefined behavior as well in this piece. And what's that? So when you're trying to build the real system, the FHIR search is almost always not enough. So when you're building the kind of encounter list in EHR, so the FHIR search is not enough. You have to join resources, apply very complicated stuff, filters and queries. So that's another problem. But I understand that we're trying to use FHIR beyond the border it was designed for. But that's very interesting experience. And for example, from developers' point of view, most of developers look into profiling as a validation engine, like validating the business rules and all this stuff. And again, just profiling is not enough for that, because you may imagine they want to put unique constraints and some other constraints which is not supported by FHIR, which exists in a one real system, yes, but doesn't exist in the standard space. And that's interesting how we can move the FHIR profiling to serve to developers as a validation engine, or maybe extend it. So that's challenging. We are thinking how to make that work together.
All right, well, again, thanks everyone for joining. I think let's wrap it up. I posted a link to provide a feedback about the FHIR meetup to this chat. Please take a couple of minutes to fill it in if you don't mind. We really appreciate it. Special thanks to speakers. It was really a pleasure having you, and I'm sure it was very useful for many attendees today. Thanks for that, and I hope to see you at our next events. Okay.
Thank you so much for having us.
Yeah, and I would say I think more. So so if you have some age topics for the FHIR meetups, yes. So pragmatic application of FHIR in real life, let's bring it to this meetup and let's have a discussion. So that's why we organize these meetups.
That's one of the questions in the feedback form.
Okay.
So, yeah, please submit your topics, propose speakers. Yeah, would love to have you. Even if you propose yourself as a speaker, would love to have you. Right. Bye everyone. Again, thanks, and see you soon.
Thank you. Bye.
Thank you.
Thank you, everybody. Bye-bye.